product based on Bacillus sphaericus, or now the name changed to Lysine Bacillus sphaericus. And we're still using same number of replications and same number of cups or concentrations within the range from low to high. And again, this range is decided by literature and also our experience. As you can tell from here, is 0.005 parts per million up to 0.015 parts per million, then 0.025 parts per million, and 0.075. You probably have an impression this range is somewhat in between BTI, spinosad, and the methylprednisolone. Methylprednisolone is much broader than this. The other two, spinosad and BTI, is narrower than this. This one's right in the middle. It's all something. There's something to do with the mode of action, their dose response range. If they're narrow or broad. So as I suggested earlier, when everything's clean, we want to start prepare the cup water larvae before you touch your pesticide. Particularly when you have a suspected resistant material, you're not going to use this. You're going to use 10 times, 100 times, even 1,000 times higher than this. You need a lot of material. In that case, you do want to start this first before you touch that high concentration of pesticide. So still 100 ml water. So one of the differences I want to emphasize is Sphaericus against mosquitoes. If there are no resistant issue, this is a very active material. So as you can tell from the range, the concentration is lower than BTI. It's worked really well in the fractional parts per million level. However, the action is slower than BTI. That's why we need longer. We'll talk about it later on. This is the 48 hours test instead of 24 hours. And also exclusively by ingestion. That's why you have to use somewhat younger larvae compared with the BTI and the spinosad. As you can, this larva I call late third instar. You don't want to use late fourth for sure, even middle fourth, because they slow them down. And you take 48 hours to kill, and by the time you read the results, actually, a good number of them are going to skip your treatment. So you want to make sure they have enough window time to feed. So again, I like to use the screen so you don't traumatize the larvae. Hopefully, you take the larvae out of here and then touch the water, let them swim away. You can count. I normally like to go 5, 5, 5 really quick, about 25. You will used to it when you do it for years. So put 25 larvae here. And do all these cups. And the larval food, you're going to use the same thing as BTI and the spinosad. I call it, approximately 10% suspension. If it can wait, you can make your own, but all you need in drops. You don't have to make a whole lot. Let them soak here. Take some minutes, and when you prepare other things. And finish all this cup, your low to high, your untreated control, 100 ml water, younger larvae, 25 in 100 ml. So they're ready to be killed. So now you move to your test material. As you can tell from the concentration range, they're quite low. So likely you're going to need more dilutions, as you can see from 5 vials here instead of 3 or 4 for other material. The material we use for this test, some similarity compared with the BTI, can be technical grade, like technical powder with 1,000 to 2,000 ITO per milligram. Or you can use this WDG, or water dispersible granule. There are fine granules with 650 ITO per milligram, quite a potent material. This is most common, probably the easiest material you work with. even easier than the technical powder. So you're going to label and start from 1%. Then 0.1%, 0.01%, 0.001%, and the last one is your 0.0001%. Well, why down to the 0.0001%? This is all based on publications and experience. So you need to down that level. The goal is your dilution here versus your final concentration here is you want to add somewhere from 100 to 1,000 microliters to that 100 ml cup, so you don't have to consider the difference your added amount costs in this 100. And also, if you make it too concentrate, you end up with using a smaller amount, tiny amount, you're going to have a greater error. If you dilute too much, you end up with add so much, you're going to change your final volume here. So we control in the range of 100 to 1,000. You bleed. Because we're going to make a 10 times dilution start from 1% in the volume of 20. So you need 20 for the first one. Then the rest will be 18. The rest is 18. I'm adding 10 first. Then I'm going to top off with by 8. Off by 8. So verify, after this, you add all the vials. Take a look. Your first one's 20, then the remaining 4 is 18. You should see the difference when they line up. And this material, like I said, they're very easy to suspend in water, even easier than technical powder, actually. And it's very easy to suspend. Just some gentle agitation will do it. You shake it until you don't see granules. When you hold like this, let it shrink a little bit, you don't see the granules. I still see a few. You can shake a little more. And then you don't see it. Very few now. So almost none now. So you can use that. Remember, this is not a solution. This is a suspension. You're gonna settle when you're holding that still. But it doesn't matter. You shake before you take. You're gonna make a 10 times dilution from here. You will need to transfer 2 mils from the upper to the lower. See, you shake before you take, and you shake, then you take. Don't wait. So the further dilution will be easier because the lower concentration, you just gently shake it, take it before it settles. Do the same thing for the next one. So at the lower concentration, as you can see, the water is so clear, suspension is so clear. You probably don't know if you're making a mistake here, but the mosquito larvae are going to tell you later. Now you finish the dilution. If you want to take a quick look now, you should have the last one now is 20. The first 4 are 18 because you're shifting 2 mL down. You take a look at that, just verify what it looks like. If you make a mistake, all of a sudden one of the things is lower than it should be, well, there's something wrong. All right, so they're ready for treatment. So once again, this dilution matches this concentration range with adding volume, from 100 to 1,000 approximately. For example, the first one, the lowest concentration, my calculation is I need 500 microliters of the 0.0001. See, the last one, the 0.0001% suspension, if I add 500 microliters to this 100 ml, my final concentration is 0.005 parts per million. You can do the 3 together, then you move from low to high. You don't have to change the tip here. But for demo purposes, I'm done with all this. Make all treatment from low to high. And of course, leave you entry control, not treat it. So after this, you remember I mentioned earlier, Sphaericus, the acting a little slower than BTI, to need 48 hours to read the results at 82 to 84 degree Fahrenheit. So with that, the food, yeah. Remember, we explained why we need some food. There's some argument about food or no food. If you add too much food, of course, that may impact the activity of the microbial agent. If you don't add food, they have nothing to eat, you may have, particularly for longer hours of test, like 48 hours, may have larval mortality in untreated control even. And also the food materials serve as a stimulant to maintain their active feeding activity. So we have a somewhat enhancement of larvicidal activity. So slurry of the 10% rabbit pellets, we put a couple 3 drops as a general recommendation. So for the food part, the only difference is the methylprint test when you need about a week, 5 days at least. You want to make a little chunk, like 100 milligram chunk into it. Other tests are using 10% suspension to feed larvae. So with that, just wait for 2 days and then come back to read the results. So after 48 hours at 82, 84 degree Fahrenheit, you can take a quick look, did you get a range or not? Actually, most of the time, if everything's right, by later hours of day 1 or early hours of day 2, before the results reading time, you should be able to see approximately the range. What I mean by saying range is you should see very minimal mortality at the lowest concentration, then increase gradually. And at the last one, you should have very, very few survivors here. And most of the larvae, they're already dead, and even darkening and down to the bottom. So If you remember how the dead larvae look like in spinosad, they're shaking, they're moribund ones, and so the body becomes shorter. This is the different. This is just stretch, dead, dark, even breaking down like that. In terms of that, the reading of the mortality is easier than spinosad. It's somewhat similar to BTI. As you can see, the larvae from here, they are bigger than the time you set up the test. Like I said, you want to use somewhat younger larvae, give them enough time to feed. That's why if you use the older one, 48 hours, by the time you read, you do not want to see any pupae now. If you see pupae in the cup, meaning the larvae used a little bit too old, then you could have misleading results. You may say, oh, my larvae is not as susceptible, maybe a tolerance there. Oh, the product may be not performing, give lower mortality. Actually, because the larvae use is a little bit too old. So, same as the BTI and the spinosad, what you read is you put a 25 here. Instead of looking for the dead ones, you blow the water and stir up a little bit to see how the larvae respond to your disturbance. Then you pick the ones that are diving, swimming gracefully. Those ones are the healthy ones. You count as survivors. Well, the remaining will be what? And then you count. The first concentration, mostly you're going to take you a minute to remove all the survivors. Okay, at the end, you got one dead, another one's dying. Okay, you record your mortality, 2 dead ones here. The moribund ones that are not maintaining their body position, they moving in a strange way, so those ones are considered as dead. As long as you're doing the consistent way, you're fine. And then you finish all the lowest 3 replication first, and then you move to the high one. Then until control, of course, you do the same. You rather probably do the first before your cups and droppers clean. You should not see many dead ones at all. Even 48 hours test, you should have very minimum mortality, couple 3 or none, like that. If more than that, you have the options to correct the mortality or redo it. I'd rather redo it if I have some suspect contamination. So this is the result reading for Sphaericus. It's some similarity as the BTI and the spinosad, but the key is you don't want to see any pupae at this time. Record dead ones, and after that, you will plot the raw data here like before. This is the paper associated with you all the time. It does give you approximately a straight line like this, log scale versus the probit, or give you like this. But if the test did give you this, is there any value of this? Of course, it still have a value. You can estimate the line through this. You can guess next time where your range should be, to the left or to the right, or which concentration give you more variability. Obviously, this one, you don't know, should I take this one or this one? Because these 2 kind of scattered. You want to have one here and here. It gives you some indication, help you next round. So with that, that's the result reading for Lysine Bacillus sphaericus, or what's formerly called the Bacillus sphaericus.